7. Let's move on to 2.7. 2.7, we're going to talk about solving equations in one variable. Okay, so basically, kind of what you've been doing all along. Okay, just doing one variable, solving the equations. So let's jump right into it. And let's look at example number 1. Example number 1, we have x plus over 3 is equal to 4. Okay. So what do you, whenever you have a variable underneath, okay, in the denominator, you always have to make your, wonder, is that going to be 0? Is it allowed to be 0? What happens if it's 0? And all kinds of stuff. So in here, obviously x cannot be 0, correct? Because you cannot divide 3 by 0. You're not allowed to do that. So in the back of your mind, you should keep this into your head saying, okay, x cannot be 0, okay? So knowing this, I'm going to go ahead and now multiply everything by x, right? If I multiply everything by x, because I've already assumed that x is not going to be 0, I'm going to get x squared plus 3 is equal to 4x. Now it looks like I have a quadratic equation, so I'm going to move the 4x over. I get x squared minus 4x is equal plus 3 is equal to 0. Okay, so now I do have a quadratic equation, so I'm going to go ahead and try to factor it first. So there are two numbers that multiply to this and add to this. Yep, there'd be -1, -3, right? -1 times -3 is +3. They add to -4. So x minus 1, x minus 3 is equal to 0. Therefore, this can be 0 or this can be 0. So either this is 0 or this is 0. So here I get x is equal to 1. Here I get x equal to 3. So x is going to be equal to either 1 or 3. 1 or 3. Either one of them works. Okay? So that's your answer. And none of them were 0, so that's good, right? Just kind of want to double check there that it's not 0. Okay. So you've done this before. Okay. There's nothing new here. This is just a review of what you've done before. So example number 2. We have a similar thing. Okay, again, I have the x is in the denominator, therefore I know that in the back of my mind this has to be true. Okay, so now let's go ahead and multiply both sides by x minus 4. So we get x times x minus 4 plus 1 is equal to 0. I get x squared minus 4x plus 1 is equal to 0. Okay, so nothing's happening here, right? I can't factor this, right? There's no factoring here. So if I can't factor it, I immediately put it into the quadratic equation. Quadratic equation says minus b plus or minus b squared, which is 16 minus 4 times a times c divided by 2a. Okay, minus 4 plus or minus square root of 16 minus 4 is 12. 2. Okay, again, at this level of math, if you leave it like here, you will not receive full credit. You have to be able to realize that 12 is 4 times 3, right? Square root of 4 is 2. So you can pull that 2 out. Now you divide everything by 2. And that's my answer, right? -2 plus or minus square root of 3. Okay, and neither one of them are 4. So hey, we're good. Life is good. Okay, no problems. Okay. Okay, move on to example number 3. Okay, example 3, now we're going to talk about extraneous solutions. Okay, extraneous solutions. Extraneous solutions is an extra solution. Extraneous solutions. Okay, it's an extra solution, a solution that does not belong there, a solution that is kind of masquerading as a solution when it's really not. Okay, it's an extraneous solution, right? Okay. Extraneous solutions, let's go and see what that is. Let's see if we can find one of those. Let's do example number 3. 2x over x minus 1 plus x minus 3 over 1 is equal to x squared minus 4x plus 3 over 2. Okay, so 2 things here. First thing we have to do is we have to go ahead and realize that this guy here is factorable to x minus 3 and x minus 1, okay? And that's what makes this question easy to handle. So this is going to be x, so this is going to be, if I factor this out, it's going to be minus 3 minus 1, because minus 3 times minus 1 again is 3, and you add minus 1 and minus 3, you get minus 4. So this can be rewritten as x minus 1, x minus 3. Okay, now I have these guys in underneath in the denominators, which means that x cannot be 1 or 3 because I cannot divide anything by 0 again, right? So I know that in the back of my mind, x cannot be 1 or 3. Given that assumption, now I can go ahead and multiply both sides by x minus 1 times x minus 3. Okay? So in other words, or another way to think of it is I can go ahead and do the common denominator thing here. Say this is 2x, x minus 3 equal to x minus 1 times x minus 3 over 2. Okay, now I can go ahead and multiply both sides by x minus 1, x minus 3, and those cancel out, so I end up with just what's on the top and what's on the top here. The top here is going to be 2x squared minus 6x plus x minus 1 over here, I end up with 2. Okay, so I'm going to combine these two together. So I'm going to get minus 5 here. That goes away. And move the negative 2 over, so it's going to be negative 2. This is what I end up with. Okay, so I'm here. So what do I need to do? Now I can go ahead and factor it. 2, 1, 3, 1, negative, positive, right? Negative 6 plus 1 is negative 5. So this is going to factor out to 2x plus 1, x minus 3 is equal to 0. Okay, when you do the factoring like this, you always want to verify that you are correct. 2x squared, negative 6x plus x, so it's going to be negative 5x. Multiply these two together, I get negative 3, so yes, this is true. So x can be either negative 1/2 or 3. Okay, so here's where we find our extraneous solution. I have 2 solutions here, but we made the assumption over here when we multiplied both sides by negative x minus 1 and x minus 3. So this is not a solution. It is masquerading as a solution. It is an extraneous solution that does not work. So our only solution is this guy, x is equal to negative 1/2. Okay, so that's what an extraneous solution is. Okay, let's do one more. Let's see if we can do the extraneous solutions. Okay, now example number 4, x minus 3 over x plus x plus 2 over 3 plus 6x squared plus 2x is equal to 0. Okay, so again, this is x plus 2. If you pull the x out over here in the bottom, you get what? You get, this is x times x plus 2, okay? Which makes it a lot easier when we're going to do the common denominator, right? So let's do the common denominator first. X plus 2, x minus 3 times x plus 2, and then I multiply this so I get 3x. And this guy here is nothing more than just the 6 is equal to 0, right? So actually, let's go ahead and move this. We'll do one more time. And when I get this, I get what? X squared, negative 3 plus 2x. So I have negative x. But I have this. So if I combine that together, I get 2x. And then I have negative 3 times plus 2 is negative 6. That cancels out with this guy here. So all I have left over is that. Okay. So I'm going to get x squared, and then I'm going to get the bottom is x plus 2 is equal to 0. So what do we have here? I have x plus 2 over x plus 2 is equal to 0. So when does this work? So this cancels out, right? And it's 1, right? So I have 1 is equal to 0. So this never works, right? There's nothing, it doesn't work, right? So even though it looks like you have 0 and negative 2 as an answer, because this makes the top 0, the problem is that both of those make the bottom 0 also. And you're not allowed to have zeros in the bottom. So neither one of these work. So basically you have no solutions. Okay? Another place that you guys have experienced this, okay, is, and let's see if I can jog your memory here, is when you solve things like stuff like this, right? So if I have 2x plus 3, and this is x, okay? The restriction that you have, the implied domain issue, implied restriction that you have here is that 2x plus 3 has to be always greater than or equal to 0, because you cannot have a negative underneath the radical, right? So if I go ahead and, so in other words, x has to be greater than or equal to negative 3 over 2. If I go ahead and solve this, what do I get? I get 2x plus 3 is equal to x squared, because I'm squaring both sides. X squared minus 2x minus 3 is equal to 0. Oh, so this is not a good example. Does that work? Okay, so in other words, so if I did that, okay, I can't come up with an example right off the bat, but when I do this, okay, when I do something like this, okay, I always want to have this guy. Sometimes when I solve the quadratic equation that comes out from this, I will get something that does not work here, okay, because it makes this guy negative. So that's another place where you could have seen this in your prior math experiences. So that's another place where you can get extraneous solutions, all right? Okay. Okay, we'll stop right here and we'll do the applications in the second half, during the second half. So